Hello students, in our previous video, we calculated area of sector using formula theta upon 360 into pi r square and also learned to find out length of the arc of any sector using formula theta upon 360 into 2 pi r. In our today's video, we will learn to find out area of segment. But first, let's recall that segment of a circle can be defined as a region bounded by a chord and a corresponding arc lying between the chord's endpoints. In other words, a circular segment is a region of a circle which is created by breaking apart from the rest of the circle through a secant or a chord. Now look at the figure where AB is a chord of the circle with center O. Chord AB divides circle in two segments. So, shaded region APB is a smaller segment of the circle. You can also note that unshaded region ADB is bigger segment of the circle formed by the chord AB. Thus, the segment having a larger area is known as the major segment, and the segment having a smaller area is known as the minor segment. Let's also quickly recall the properties of segment of the circle. The angle subtended by the segment at the center of the circle is the same as the angle subtended by the corresponding arc. A minor segment is obtained by removing the corresponding major segment from the total area of the circle. A major segment is obtained by removing the corresponding minor segment from the total area of the circle. If the chord forming the segment is diameter, then the segment formed is called as semicircle. Note that in this case, both the segments are equal. Now, let us derive the formula to find the area of segment so formed by chord and the corresponding arc. The formulas for area of segment is as follows: area of the sector minus area of the triangle. That is, area of segment is equal to area of sector minus area of triangle, which is equal to theta upon 360 into pi r square minus 1 upon 2 into b into h. Let us consider the minor segment of the circle, that is made by chord AB of a circle of radius r and center O. We know that every arc of a circle subtends an angle at the center, which is referred to as the central angle of the arc. Say the angle made by the arc ACB is theta. Now, if angle AOB is equal to theta, then the area of the sector AOBC is given by the formula area of sector AOBC is equal to theta upon 360 into pi r square. As we know that the area of the segment ABC is given by area of sector AOBC minus area of triangle AOB, which gives us theta upon 360 into pi r square minus 1 upon 2 into b into h. Now, students, the area of triangle AOP can be calculated in two steps if it is not given to us. Draw the perpendicular from O, the center of the circle, to opposite side AB. Note that the perpendicular OP is the height of triangle AOB, which can be calculated using Pythagoras theorem as shown. If the length of AB is given, then for right triangle OPB, OB square is equal to OP square plus PB square. Therefore, OP square is equal to OB square minus PB square. Therefore, OP is equal to under root OB square minus PB square. Note that here OA is equal to OB because both are the radius of the circle, and AP is equal to PB as OP is perpendicular bisector of AB, or In case when theta is given in degrees, OP is equal to r cos theta upon 2. Or calculate the area of triangle AOB using the formula area of triangle AOB is equal to half into base into height, which is equal to half into AB into OP. Note that to find the area of major segment of a circle, we just subtract the corresponding area of the minor segment from the total area of the circle. Students, considering the same segment again, can you guess what will be the perimeter of the segment ACB? We know that the segment of a circle is made up of an arc and a chord of the circle. Consider the same segment as in the given figure. Recall that perimeter is outer boundary of the shape. Therefore, perimeter of the segment is equal to length of the arc plus length of the chord, which is equal to theta upon 360 into 2 pi r plus length of AB. In our next video, let us solve some examples.